second one I want to talk about is this regression and correlation worksheet here. And it has two scatter plots. And it says there's a relationship in scatter plot 3 positive or negative. And I would say this one is positive because it's kind of going up slightly as you're going this way. And in scatter plot 4, it's also positive. So if you were to see a negative one, it'd start at the top and go down to the bottom, start at the top, go down to the bottom. Which one has a stronger relationship? Scatter plot number 4 does. Okay, so this correlation might be 0.8, and this one might be, and remember that's our R value. This one might be maybe 5 or something. So this one is a stronger one. Okay, so correlation coefficient tells you how strong some data is. Okay. The next question says, a survey was done at Ketchum High School to determine the effect of time spent on studying grade point average. The table below shows the result for 10 students randomly selected. It says, use this information in your calculator to make a scatter plot. So, if you look, and this is how you can kind of tell what kind of pattern or regression a line has. So if you go to Stat Edit, you're going to enter this data in your calculator, just as we've been doing the past couple days. So take a minute and enter that in there real quick. Okay, and that's 10 data points, so okay, so hopefully you should have your even list, okay, and then you're going to go to second stat plot, make sure that that's on, make sure it's highlighted, and you're going to go to zoom 9, okay. Oh, and I have line of best fit equation in there from before. So this looks like it's a linear regression because it's kind of following the shape of a line. And there's an outlier right here, that's okay. But most of the data is going in a linear pattern. So this one is linear. Okay. So that's so I know it's going to have a linear regression. So then I can say, okay, I need to use the linear regression function on my calculator to determine the equation. So if I go to stat calc, I want to go down to linreg because that's my data is linear. Okay, and so tomorrow we're going to work with data that's exponential or quadratic, and that's when we'll use some of the other functions there. So it looks like it wants us to round to the nearest tenth, so you should have y equals. My a, or my slope, is 1.5x, and then my b value is 56.9, but it wants us to round up, so it'll be 57. Okay. And then it says, what is the correlation coefficient? In this case, it's 0.3. Okay, so this data looks relatively weak. So the correlation coefficient is positive because it should be going up. As the time goes up, your GPA goes up. That makes sense. And then our correlation coefficient is 0.3, which doesn't necessarily follow what we're seeing in our graph here. It looks like it's a pretty close line. I wonder if we can zoom in any farther. Zoom fit. Okay, so I'm going to type that equation in, 1.5x plus 57. Okay, so you can kind of see that outlier is bringing that line of best fit down. So the line of best fit, maybe I typed something in wrong. Yeah, I did. Okay, this is supposed to be 86. That's why. Okay. Sorry. Alright, there we go. Alright, so let's do stat calc. And let's go to our linreg. All right, so this should be actually y equals 1.6, 1.7 x plus 62. All right, so that's better. And my correlation coefficient changes now 0.9. It's actually 0.98 if we round to the nearest. So that's pretty high, which means that line, if I put the line into my y equals, it should be very, very close to all my data. So that's very strong. So that makes sense that that correlation coefficient is so high. Okay. So then it says, so then it wants you to make a prediction based off that. So this linear is definitely a good model for this. And like I said, tomorrow we'll look at stuff that's not so linear. Okay. So take a minute. Today's really just focused on making sure you're picking the correct regression function and then finding the correlation coefficient, which is the R value, not R squared value, the R value, and that'll tell you how strong a data set is. Okay? Sorry about that, but thanks for watching.